Okay, today I'm going to talk about the vertex form of quadratic equations. All right. This is not too bad to do, but it's really it's really dealing with making sure you understand uh, completing the square. Because if you can understand completing the square, then vertex form is not going to be that hard for you. So the first thing about vertex form. All right. Well, this is an example. This is the standard form for vertex form, right? It's something in this form, y equals a parentheses, right? X minus h squared plus k. So when you write things in this form, so for example, y equals 1 times x minus 1 squared plus 2, you know that the vertex of this quadratic equation, right? The vertex of this graph is going to be whatever you're subtracting here. What am I subtracting? I'm subtracting a 1, so the vertex is at x comma x is 1, and whatever you're adding here is your y coordinate, so 2. So it crosses 1 comma 2. So if I was to graph that, right? If I was to go up here and graph that. Oops. So if I go in here and I graph something like this, y equals x minus 1 squared plus 2. What you're going to notice is if I trace this and I start moving, look at the vertex. Watch the vertex. The vertex, the minimum, is at 1, 2. So this is called vertex form because it gives you the vertex, right, if you write things in that form. And what's neat about it is you can change the leading coefficient, right? You can put a different number in front of it, but it doesn't change the vertex. Watch. 2 at times x minus 1 squared plus 2. In fact, the 2 there, all it does is makes it narrower, right? It stretches the graph. So as long as it's minus something squared inside plus something at the end, that's called vertex form, all right? So let's just graph a couple of these. First things first, we're just going to graph them, okay? A couple little things that you should probably already know, but if a is greater than 0, then it opens upward, right? Right? And that means like this, that's opening upward, right? And if x is less than 0, it opens downward, right? And the axis of symmetry will be wherever h is. So that'll help us a little bit. All right, so here we go. These are actually really easy to graph. So the first things first, we need to find the vertex, right? Remember, the vertex is going to be found at whatever's being subtracted here. What's being subtracted? 3. And then what am I adding to it? 5. So the vertex is at 3, 5. So if I go to 3, 5, 1, 2, 3, 4, 5, right? 3, 5. Put a dot there. I know the axis of symmetry is there because the vertex is always on the axis of symmetry, right? So somewhere on that line. Okay. And then we got to pull some more points out. Well, it's really easy to pull points out of a vertex form because you can pick numbers real easily, all right? So for example, we could put, like if we put a 4 in, right, for x, you can see that 4 would actually make real fast, right? 4 minus 3 squared plus 5. So picking 4 is smart because 4 minus 3 is easy, right? So 1 squared is 1 plus 5 is 6. So 4 is 6. So we go to 4, 6, put a dot there. And we reflect it. Remember, the line of symmetry reflects the graph. So let's try 5 then, right? So let's do it. 5 minus 3 squared plus 5. Well, that's 2, so that's 2 squared plus 5, so that's what? 9. So 2 is not 2, 5 is 9. And then I would reflect it 2 to the other direction, right? 2 that way, 2 this way. So there it is. There's my graph. And they're real easy to graph because they give you the vertex, right? All right, so let's do it again. Notice this one's a little bit trickier, right? Because this is addition. And if you look at vertex form, it should be subtraction, right? So it's addition. So we're going to first understand where the vertex is, right? Where is the vertex? So what am I subtracting here? Well, if I rewrote this, this would be minusing a negative 3, right? Subtracting a negative 3 is the same as adding 3. So where's the vertex at? Negative 3. And then what am I adding here? Well, if I rewrote this as addition, it'd be plus a negative 3. But the best way to do is just look at the chunk, right? The chunk is negative 3. So be careful with this part, right? This has to be subtraction. And this one has to be addition, right? So what am I subtracting? The opposite of adding 3. So negative 3. What am I adding? Negative 3, right? So the vertex is at negative 3, negative 3. So we're going to put a dot there. Okay. And then we just pick a couple more points. Make sure I'm recording here. That would be the worst. All right. So let's just try some points. I try 0 would actually be good here, right? 0 would be good. I should draw the line of symmetry while I'm at it so I can. So let's try 0. 0 plus 3 is 3. 3 squared is 9. 9 minus 3 is 6. So 0 is 6. So 0, 6. And I went 1, 2, 3 that way. So I'm going to go 1, 2, 3 this way, right? And I guess negative 2 would be smart, right? Check negative 2 because it's really close to the axis of symmetry. So negative 2 plus 3 is 1. 1 squared is 1 minus 3 is negative 2. So it's negative 2, negative 2. Reflect that. All right. And I guess I'll try one more point. Probably negative 1 would be smart, right? So negative 1 plus 3 is 2. 2 squared is 4 minus 3 is 1. Just plug in the numbers and figure out what's happening. So negative 1 is 1. So there it is. Like I said, real easy to graph. Okay. All right, let's try it again. Now, the first things first this time. There's a 1 here, right? I don't care that this is negative. All that negative is going to do is go back to the beginning, right? If a is less than 0, then it opens downward. So you know it's going to be graph like this, right? Opening downward. So it's going to have a maximum. So the negative 1's not going to affect that. It's not going to affect our vertex. So our vertex, remember, what am I subtracting here? I'm subtracting a negative 2, right? So it's going to be negative 2. What am I adding here? A negative 4, right? Okay, so the vertex is at negative 2, negative 4, and it's opening downward, so I know it's going to do something like this, right? I don't know what it looks like yet, but I know it's going down. So let's try some numbers. So negative 1 would probably be easy, right? Negative 1. Negative 1, so we might want to do this. Negative 1 times negative 1 plus 2 squared minus 4. Well, negative 1 plus 2 is 1. 1 squared is 1 times negative 1 is negative 1 minus 4 is negative 5. Just be careful with that math, right? You could mess it up real easy. So negative 1 is negative 5. And you can see, oh, I need my vertex, don't I? I mean my axis of symmetry. So there it is, right? So it's reflected. So I guess I should try 0, right? 0 plus 2 is 2. Squared is 4 times negative 1 is negative 4. Minus 4 is negative 8. So 0 is negative 8, right? And I would reflect it 2 to the other direction, so it's here. So there's my graph. Pretty easy. All right. Now, next problem. This time, these are not in vertex form, right? They don't look like this, right? They don't look like this. We need to rewrite them. So here's what we're going to do. First thing you need to look at, make sure that the coefficient here is 1. If it's not 1, we're going to have to deal with it, okay? But it is 1 in this first problem. So the first thing we're going to do is we're going to move the 6 to the other side. So we're going to get y minus 6. I'm going to leave a blank here, and you'll see why in a minute. X squared minus 2x, right? And I'm going to subtract 6 from both sides. So I end up with y minus 6 plus something equals x squared minus 2x, right? Okay, so here's what we're going to do. What do I need to add to negative 2x so that this could be a square? That should look familiar to you, right? Because that's just completing the square. So what do I need to add to both sides, right? So that I can make a square. Actually, I don't need this part here. All right, so here we go. Remember what we did. That's going to be x. Take half of negative 2, negative 1. Square it is 1, right? So I'm going to add 1 to both sides. So what do I end up with? I end up with y minus 5, right? Is equal to x minus 1 squared. Now, I'm really close to looking like vertex form, right? All I have to do is get the y by itself, right? And have something at the end. So what do I need to do? I need to bring the 5 back over. So what I end up with, y equals x minus 1 squared plus 5. And that is in vertex form, right? So where's the vertex? The vertex is at 1, 5, because I'm subtracting 1 and I'm adding 5, so 1, 5. So 1, 5 is here. All right. Put another number in. I'd put a 6 in. 6 would actually be smart because 6, oh, no, not 6, sorry. Yeah, no. I'd put in a 2. 2 would be smart because 2 minus 1 is nice and easy, right? So 2 minus 1 is 1. 1 squared is 1 plus 5 is 6. So 2, 6. So I know my vertex is here, right? And my axis of symmetry is here. So 2 is 6, so I would reflect it. Oops, nope, not there. Here. So I'm going to try 3. 3. 3 minus 1 is 2. 2 squared is 4. 4 plus 5 is 9. So 3, 9. So put 3, whoa. So put 3, 9 on the graph. It's here. Reflect it. It's here. So there's my graph. Okay, so don't let this part mess you up. All I'm doing right here is just completing the square, right? Without actually finishing the problem. The only difference is I bring the 5 back over at the end, right? I had to add 5 to both sides because I wanted it to look like this at the end. All right, so let's try it again. So first thing I'm going to do is bring the 5 over. Minus 5, minus 5. So I'm going to leave a little blank here. You'll see why in a minute. Y minus 5 plus something equals x squared plus 6x plus something so that I can make a square. Just like you've done probably, I don't know, 20, 25 times now, you're going to put an x there. What's half of 6? 3. So you're going to put a 3 here. You're going to square it. You're going to put a 9 here, but you're going to add 9 to both sides, right? So we get y minus 5 plus 9, which is y plus 4. Good. Now what do we want? Remember, for vertex form, we want the k at the end. We don't want the k with the y, so we have to subtract 4 from both sides. And we end up with y equals x plus 3 squared minus 4. So where's the vertex? The vertex is going to be at negative 3, negative 4, because what am I subtracting here? A negative 3, and what am I adding there? A negative 4. So it's at negative 3, negative 4. So I'm going to graph that. Negative 3, negative 4 is here. Let's make my axis of symmetry while I'm at it. All right. All right. Then let's try a couple points. I'm going to do it here. I have a little bit of room this time. X, Y. So I'd probably check a point right next to the vertex, like negative 2. Right? Check something right next to it. So let's try negative 2. Negative 2 plus 3 is 1. 1 squared is 1. Minus 4 is negative 3. So negative 2, negative 3. Negative 2, negative 3. Reflect it. I'd probably try negative 1. Negative 1 plus 3 is 2. 2 squared is 4. Minus 4 is 0. So negative 1 is 0. So it's here. Reflect it. And I'd probably check 0, right? What did I say? Negative 1 was 0, so try 0. 0 plus 3 is 3. 3 squared is 9. 9 minus 5 is 4. So 0 is... wait. Let's try that again. 0 plus 3 is 3. 3 squared is 9. 9 minus 4 is 5. So 0 is 5, right? Reflect it. And that is my graph. Like I said, when things are in vertex form, they're very easy to graph. All right. Pretty easy, I think. All right, next problem. What's different about this problem? That's what you have to figure out first, right? How is this different? Well, it has that negative here. Now listen, every problem we've done before, don't write this, just pay attention for a minute, right? These would be 0, so we would divide everything by negative 1, right? We would do something like this. This is not what we're going to do, but I'm just showing you. In the past, this was 0, so we'd make this negative 1, and we could drop the negative 1, right? because that was 0 divided by -1, we could drop it. The problem is that's not 0 this time, right? It is not a 0. It's actually y. So what we're going to do is we want to get this by itself, right? We want to make that +1. So we're going to divide everything by -1. And watch this. This is the new weird part. We're just going to have y over -1 plus something equals, what do we get? X, oh no, I'm not going to do this yet. Hold on. We're going to get y over -1 equals x squared minus 6x plus 15, all right? Then we're going to subtract 15 from both sides. So we're going to get y over -1 minus 15 plus something equals x squared minus 6x plus something so that I can make a square. Well, what's half of -6? So x minus half of -6 is 3. We're going to square it and put a 9 here. We're going to put a 9 here. Okay? Next step. Y over -1. -15 plus 9 is -6. Right? Next step, bring the 1 back, bring the 6 back over, so +6 plus 6, and I'm really close to the correct answer, okay? I'm really close to the answer for this problem. The problem is I still have that -1 that I'm dividing by. So I'm going to multiply both sides by -1, right? Now watch what's going to happen. This is going to become y equals -1 times, we're going to distribute the -1 to that parenthesis and to the 6. We're not going to multiply the x and the 3 by -1, okay? We're distributing a -1 to the parenthesis. So it's just going to be -1 parenthesis x minus 3 squared, and then -1 times 6 is -6. So where's my vertex? My vertex is at -3. Nope. Made a mistake, didn't I? It's minusing 3, so what am I subtracting? 3, -6. So the vertex is at 3, -6. So 3, -6 is here. Right? Let's find some more points. Let's see, what's close to 3? 2. Let's do 2, right? So let's go in here and do 2. So 2 minus 3, we're looking right here, yeah? We're looking at this right now. So we get 2 minus 3 is -1. -1 squared is 1. 1 minus, oh, okay, no, we do have to be careful here. I'm actually going to show you what's going to happen. Wish I had a little bit more room, okay? So I'm going to try 2, like I said, right? So I'm going to have y equals -1 times 2 minus 3 squared plus 6. Actually, minus 6, right? Minus 6. All I'm doing is I'm putting the 2 in for x. Why did I pick 2? Because it's close to 3, right? It's close to the vertex. It's close to our axis of symmetry. All right? Whoa, big color. All right. So 2 minus 3 is 1. 1 squared is 1. But then you're going to multiply it by -1. So you get -1 times 1 minus 6. So we get -1 minus 6, which is -7. So we get the first point on our graph, other than the vertex, is 2, -7, right? So 2, -7. Now, why is it below the vertex? Oh, yeah, because the number in front of the x squared is negative, so it's going to point downwards. So I got another point, and that's pretty much enough to graph it. I think the next point will be off the graph, so it does something like this, right? Something like that. Got it? All right, let's do another one. If you're watching the video today, we're probably stopping somewhere right around there, and then the next day we're going to pick up with some more, okay? All right, next problem. We cannot get rid of the -2 by dividing everything by -2 because the y is still going to have an over -2. So we're going to divide everything by -2. But we're not going to get rid of the negative 2. We're just going to have y over negative 2 equals x squared plus 8x plus 12. Then we're going to bring the 12 over, right? Just like we did before, bring the 12 over. So we're going to get y over negative 2 minus 12 plus something equals x squared plus 8x plus something so that I can make a square. Excuse me. So half of 8 is 4. Square it, 16. So I'm going to add 16 to both sides. So what do I get? I get y over negative 2 plus 4, because negative 12 plus 16 is 4, equals x plus 4 squared, right? Bring the 4 over, minus 4 minus 4. I get y over negative 2 equals x plus 4 squared minus 4. I'm going to multiply both sides by a negative 2. So I end up with y equals negative 2 parentheses x plus 4 squared minus 4. Oh, not minus 4. I just made a mistake. That was not on purpose. You got to distribute the negative 2 to the parentheses and to the negative 4, so it's actually plus 8. So where is my vertex, right? Where's my vertex? My vertex is going to be at, what am I subtracting here? Right? What am I subtracting here? A negative 4. And what am I adding there? An 8. And some of you guys might look at this negative 2 and think that since it's subtracting 4, you're going to multiply it by a negative 2, but it's just not true, okay? That actually is going to be the vertex, all right? So the vertex is at negative 4, 8. Negative 4, 8. Put a dot there. Right? So my axis of symmetry is right there. It's going to point downwards because the coefficient of the x squared is negative. So let's try some more points. If it's at negative 4, let's try negative 3, right? So negative 3. So let's try negative 3. You're going to have to do some work here, so just be careful, right? So we're going to get negative 2 times negative 3 plus 4 squared plus 8. So what do we get? Negative 3 plus 4 is 1. 1 squared is 1 times negative 2. So we get negative 2 plus 8, which is 6. So negative 3 is 6. Negative 3 is 6. That looks about right. Reflect it. And let's try 0. 0 would probably be good, right? So negative 2 times 0 plus 4. Oops, I'm running out of room, right? Negative 2 times 0 plus 4 squared plus 8. Well, 0 plus 4 is 4. 4 squared is 16 times negative 2 is negative 16. Actually, no, bigger than that, right? 4 squared is 16 times negative 2 is negative 32 plus 8. I'm already off the graph, aren't I? Okay, if I'm off the graph, then I'm going to have to pick a different number, right? So maybe not 0. Let's just try negative 2 then. So we got negative 2 times negative 2 plus 4 squared plus 8. Negative 2 plus 4 is 2. 2 squared is 4. 4 times negative 2 is 0 plus 8. So it's 8. 0 is 8. 0 is 8. Okay, so look at this. I get 0 is 8, and that tells me that I just made a big mistake. So where's my mistake at? If you do this tonight, you're going to have to find your mistakes, okay? So I just found my mistake. So if you get a point way up here, and you know it's going to have to be down here somewhere, right? It's going to have to be down here somewhere, so you know that's not right, right? All right, so what did I plug in? A negative 2, right? Negative 2. Negative 2 plus 4 is 2. 2 squared is 4. 4 times negative 2 is negative 8 plus 8 is 0. Okay, I know what happened. I used 0 instead of negative 2. So negative 2 is 0. So there it is, reflected right here. And that's probably enough for us to graph it, right? Something like this. All right, one more problem. So let's try it. All right. Now look at this. These are all multiples of 3, but not this. But we're going to have to deal with it anyway. So I'm going to kind of write small because we're going to have to fit a lot of work in here. We're going to divide everything by 3, right? Divide everything by 3. So we end up with y over 3 equals x squared minus 10x plus 80 thirds, right? Then we're going to subtract 80 thirds from both sides. So what do we get? We get y over 3 minus 80 thirds plus something equals x squared minus 10x plus something so that it can be a square. Well, it's going to be x minus 5, which means we're adding 25 to both sides. Now, if I were you, since that's in thirds, I would actually call the 25 and think to myself, what is 25 as thirds? 25 is equal to 75 thirds, so it might be better on this side to call it 75 thirds. Okay, because 25, if you cut it up into, each piece is cut up into 3 pieces, you'd have 75 of those, right? So 75 thirds. All right, so now what do we get? We get y over 3 minus 80 thirds plus 75 thirds is minus 5 thirds, right? Bring the 5 thirds over. Bring the 5 thirds over. We get y over 3 equals x minus 5 squared plus 5 thirds. Then multiply everything by 3. And we finally get y equals 3 parentheses x minus 5 squared. Now 3 times 5 thirds is 5, so plus 5. So where's the vertex? The vertex, what am I subtracting? I'm subtracting 5. What am I adding? I'm adding 5, so it's 5, 5. So it's right here. All right, there's the vertex. That means there's my line of symmetry. Going down there. Bad line, but you get the idea. All right, let's try some points near 5. Let's try 6, right? So let's go into here and try 6. So what do we get? We get y equals 3 times, oops, I'm gonna make my table first, right? So x, y, let's try 6, right? So we get 3 times, whoops, we get 3 times 6 minus 5 squared plus 5. So we get 1 squared is 1 times 3 is 3. 3 plus 5 is 8. So 6 is 8. 6 is 8. That's up here. And I can already tell that the next point is going to be off the graph. So I think that's enough for me to graph it, right? Something like this. All right, something like that. And there you go. Completing the square to write things in vertex form. You know, just keep in mind that it needs to look like this, right? It needs to look like this up here. And make sure this is subtraction and make sure that that's addition, right? And if it is, whatever that x number is and whatever that k number is, that's your center. That's your vertex, all right? All right, well, good luck with that. And if you need help with it, send me an email at MathNinja.Videos@gmail.com or get on my YouTube channel and leave me a comment. And good luck with it. Have a nice day.